So, welcome back. In the last class we saw kinesthesia, the sensing mechanism of our movements, sense of position, proprioception, sense of position, and then it's a sense of balance also we saw. So, in this class we will look at how muscles are generating forces. Okay. So, how movements are initiated? Muscles are integral part of the movement generation. In a haptics, we need to apply force, we need to move our hands, we need to explore objects. So, the hands have to move and then generate force. Okay. So, the integral part of haptics is understanding how muscle is generating force. That is what we will focus in today's class. Okay. There is a lot of biomechanics involved in understanding the muscle force generation. We will not get into the biomechanical aspect of it. Very important things that is necessary for understanding the haptics part of it alone, I am going to focus on it. Much more details I covered in biomechanics course, which I used to offer in other semesters. Okay. So, only that is required for haptics course I am going to touch upon it, but there are much more details. Probably you can look at the textbook, specifically the Eric Kendall chapter 33, 34 and 35 for getting more details on what we are going to talk about today. Okay. So, we will start with muscle, let us say. It is going to generate a force. Let us say we are trying to apply force over here. Okay. So, what will happen? I am going to draw a graph. Let us say this is the length, let us say this is the force it is generating, right. So, let me say it has some original length, this is a starting length, initial length L naught, and any longer stretch is going to be L naught plus something, right. So, let me normalize this one with the L naught, and let us say 1 means it is at the resting length. I am starting to apply force. What is going to happen is, as I increase the length, it is going to be more and more tougher, it is going to be exponentially increasing, right. So, this is force required to length, right, force required to stretch. Now, you have to see that this is without any addition of electrical stimulations, it is just a we have taken a muscle out of the body and then put it in our stress strain or force application, or even with the hands you are trying to stretch it, and this is going to be your force resisted by the muscle. Now, suppose if we apply electrical stimulation. See, remember in the last class we saw that about alpha motor neuron, gamma motor neurons. Let us say this is the intrafusal muscle which is innervated by one of the motor neurons. Let us say it is electrical stimulation. Let us say when you stimulate the muscle, what is going to happen is it is going to generate force. And it is the force profile generated by the muscle when you are holding it. What happens is, whenever there is an electrical impulse, it is going to shorten it. When it is shortening, your hands are going to feel the pull force, and that force is what I have plotted over here. So, this is plus I call this profile as active, and this profile called a passive. Passive in the sense there is no electrical stimulation. Here this graph not only active, it also passive, active plus passive, because the passive properties also is there, right. It is not just the active property. So, from this I can easily find out what is the active property alone, L naught, that is going to be, this is the active property of muzzle. This is a force generated by the muzzle when it is stimulated with an electrical impulse. So, where are we generating? We are just generating here electrical stimulation. When you start over here, the muzzle start generating force and it reaches some maximum and then falls down. So, how did I do this? I have taken this curve, active plus passive, I have subtracted the passive, I got the active alone. Okay. So, the same graph I can put it in another view just for understanding. Instead of x axis on length, I am going to plot it in t, time. I want to look at how the muzzle is generating force over the time. Okay. So, y axis I am again going to keep the same f, and if you look at the time, again it is going to look similar to what we have seen it over here, but it is the x axis is t. This is called the tetanus in the literature, tetanus in the literature. So, what is that I have done? I have started the stimulation over here and the muzzle started developing the force over time, reached some maximum and then fallen down and then attained some 0 over here. Right. Now, the same thing, suppose the same muzzle, I am again plotting f and t. So, before the muzzle reaches 0, suppose if I put another stimulation, what will happen? I have started stimulating over here, the same muzzle, it is going to reach this way, but before it reaches 0, what I am going to do is I am going to put another stimulation. So, what will happen? It is going to build up force from the place where it left, it is going to summate. Okay. So, it is going to, the force, it is the summation of the force. Okay. Now, this will go on as long as the stimulation is on. Here also I am stimulating, here let us say here also I am stimulating. So, it is going to keep building on it. Okay. Let us call this as a unfused okay. This is yeah. Okay. So, unfused tetanus. Oh yeah. So, this is not the tetanus, this is called the twitch, and this is actually a tetanus. Tetanus is the saturated force value. So, if I continuously apply stimulation, what happens? Again I can put stores. So, I am not continuously, very frequently I am applying stimulations. So, what is going to happen is that is not going to be discontinuity, it is going to be continuously and reach a force over here. This is called the tetanus, not the other one. Or in some textbook you will say fused tetanus. tetanus. This one is the unfused tetanus, it is keep building it up, this is called the fused tetanus. So, this is for one muscle. We have seen how electrical stimulation is actually is used to generate a force. Now, there are different type of the force type of the muscles which has different twitching properties, twitch properties. Okay. So, understanding different type of the muscle is important. So, the one type of the twitch we have seen is over here, right, for the same stimulation. Different muscle will have a different twitch. For example, another muscle will have a much slower response. Okay. So, the peak occurs over here, whereas this muscle, let us say this is muscle 1, this is the muscle 2, muscle 2 has a slower response and this is the faster response, fast muscle, whereas this is the slow muscle. It depends upon how twitch is developing, we can classify muscles. Okay. So, why do the muscles have different rate? This is called the shortening rate of the muscles, shortening rate. The muscles are generating force during shortening, it can generate force only during shortening, and then there are different different rates for each of the muscles. Okay. And it has a purpose why different muscles have different shortening rate. There are different reasons, we are going to see one by one, but for the time being you have to understand that the shortening rates are there for different muscles. Now, according to how of different muscles are shortening, people have classified the muscles. Okay. So, classification of the muscles is important. Muscles based on the shortening rate. Okay. So, there are slow muscles, that is one type, slow muscles. Most of the literatures classify the muscles into 3 types: slow muscle, and then there is another muscle called fast resistive, F for fast resistive. Another third type is called the fast fatigable. These are the 3 different type of the muscles. Okay. Fast resistive, this fast fatigable. Okay. So, the fast fatigable muscles, they are very fast, but they are quickly fatigable. They can generate force only for very short time, they cannot generate force for very long time, those are fast fatigable. Slow muscles are they are slow to generate force, but they can generate force for longer time, they are less prone to fatigable. Okay. Fast resistive is the in between. Okay. In some of the literatures or in the textbooks, you also see something like fast glycolytic, FG is called the fast, this is fast resistive is also called fast glycolytic. Fast fatigable is also called the fast oxidative glycolytic. Pharmacologically, people have now named different type of it. Okay. In fact, in the recent time, as of now, there are many type of muscles people have identified, even subcategories of all these muscles. okay, maybe some 10 different type of the muscles people have identified. But for our understanding, if you differentiate between these 3 muscles, it is good enough. Okay. So, one way to identify each of those muscles is by looking at the color. Okay. So, the slow muscles are now red in color, whereas the fast fatigable muscles are now pink in color, or this is white in color, whereas this one is pink in color kind of things, because slow has lot of oxygen in it. Okay, it has a lot of energy in it. It looks very reddish, whereas this one, it does not have much power in it. It looks white, whereas this one is a medium power. Okay. Okay. So, again, to we have to still to answer the question why our muscle systems have different type of the muscles. Why should this be differentiated using the shortening rate? Okay. For this, I need to explain a concept of motor unit. This is one of the important concept we have to understand. So, in the earlier class we looked at muzzle, connecting to the spinal cord, motor neuron. Let us say this is the alpha motor neuron, this is the efferent. Now, it is getting connected over here. Now, in any of these muscles, there are this 3 type of muscles, or all the type of muscles are there. Okay. So, there are type 1, type 2, this all called type 2A or 2B, this what the classification is. All the type of muscles are there, but this alpha motor neuron, any one of the motor neuron is connected to only one type. So, each motor neuron is connected to only one type of muscle. It is not connected to different types. Okay. So, as many types of muscle there will be as many type of motor neurons. Okay. So, depending upon the force required, there are different type of the muscles are going to be in action. Okay. So, we are going to see this. So, the motor neuron is the motor unit is nothing but motor neuron plus all the muscles else it is innervating. So, this motor neuron may be connected to some 20 muscles or 2000 muscles, but it is all going to be the same type. Okay. So, when the motor neuron is firing, all the 20 muscles, so all the muscles it is innervating are going to be fired, all are going to generate force. So, together motor neuron and all the muscles it is innervating is called the motor unit. Okay. So, we can find out what is the size of the motor unit. It depends upon how many muscles each motor unit is innervating. Okay. So, the motor unit depending upon how many muscles it is connecting, it can be 20 or 2000. There are many different sizes of the motor units. Okay. small motor unit, small motor unit or large motor unit. It depends upon how many motor how many muscles it is actually innervating. Okay. Now comes to answer this question of why our muscle systems have different type of the shortening rate. It has to generate force at a different level at different time. Okay. So, before explaining this, let me explain the principle called the motor unit related principles called the all or none principle or law. This is also called the Bowditch law in the literature. So, this principle says that all the muscles connected to the motor neuron will be firing or none will fire. That is what the principle is. That is a concept of the motor unit. Okay. So, this is important to understand that all the muscles are either active or not active. Okay. Now, this is important because this is going to help us in understanding another principle called the size principle. This principle says that small motor units will be in action first. Why is that? Will be generating force first. Why is that? The slow motor neuron, small motor units, they are all now made up of slow muscles. They can stay there for a long time. Okay. So, small motor units, it is going to generate smaller force first. Large motor units are going to generate larger force. So, what we want is we want to gradually increase the force. So, first small motor unit has to be generated. So, how is it going to generate? The alpha motor neuron is going to send the what do you call graded potential. Alpha motor neuron is generating the graded potential to all the muscles, but only the small motor units will have action potential which is equivalent to the corresponding graded potential. Whenever this motor unit's action potential is equal to the graded potential, it starts firing, it starts generating force. Now, the motor neuron is going to increase the graded potential. Then what is going to happen is next smaller motor neuron will come into picture. So, larger and larger motor units will be generating forces subsequently. Okay. But the first small motor neuron is going to still be active because its action potential is lesser than the graded potential. Okay. So, this has to be fatigue resistant, it has to be there in action for longer time, therefore, this has to be fatigue resistant. Okay. So, the largest motor unit will be generating force at last, right, generating force at last. Okay. So, this is called the size principle. Depending upon the size, the muscles are generating force. Suppose if you are reducing the force, what happen? Then the reverse order will happen. The reverse order in reducing the force. Reducing the force, the largest motor unit will be dropped first, the smallest motor unit will be dropped last. Okay. So, the muscle generating force is actually called recruiting. Recruiting. It is like the muscles are recruited for generating the force. So, while increasing the force, more and more bigger motor units are recruited, while reducing the force, the largest motor unit are dropped first and then smallest motor unit is dropped last. This is called the size principle.
How to know muscle is larger or smaller?
So, the number of muscles attached to it.
Any specific number?
Say there are 20 is smaller, 1000 is big. Okay. 20 number of muscle fibers, there are all, each muscle is made up of muscle fibers. Muscle fibers is the one which is generating the force. So, 20 muscle fibers generating force compared to 1000 muscle fibers comparing force is larger. Okay. So, number of muscle fibers it is innervating can directly tell you whether what is the size of the motor unit.
So is the force become steady in the smaller motor unit? Like if we are dropping at last, so the force will become steady. Is it?
If you are dropping the force at last, what is the question?
It's like a smaller motor unit we are dropping at last.
Correct.
So is it like like force will become steady at certain time? Like
it depends upon what is the force requirement. If we have to maintain the force constant, then and all the motor units recruited will be in action for during the time. Whenever it is reducing or increasing, there will be a change in the recruitment. So, if you want to maintain the force, the largest motor unit which is recruited last will be still in action. It depends upon how much fatigue it can be, it can withhold. Okay. So, one way to find out, so whenever you go to your sports center, are there any athletes in this audience, right? You are athletes. Okay. So, yeah, when you go to the any training camps for any type of the sports, each type requires different type of the muscles. Okay. So, as soon as you go, the trainee is going to find out what is your composition of the force muscles. Okay. So, for this sports, this is a composition required, but your body has this is a composition. So, how much, what is the target, what are the different type of the muscles which has to be developed. For this development, what are the different exercises needed, and that is what the drilling master is going to sit and decide, and then he will give you a course. If you do this course, this is the muscles will get developed, either the fast or slow. For example, sprint needs a but whether it is a slow or fast, whereas a marathon requires slow. So, they will find out how much percentage of the muscles are slow. For marathon we need lot of slow muscles, powerful muscles. So, what are the different exercises needed to develop these slow muscles? Okay. Every sports will have this kind of analysis. In fact, now invasively they find out muscles. For example, biceps, they put a micro needle and then take a small biopsy of the muscles and then look at that, analyze it, what is the composition of the muscles. Okay. without invasively finding it out, non-invasively, can we find out what is the composition of the muscles? That is still a research question. Now you can find out an answer, and then it is a $1 million or $1 billion ideas. Okay. Now I hope the size principle is clear. Okay. The next okay, let me show you a couple of now slides to make it clear. These are the different type of the muscles I talked about. Motor unit properties, type 1, type 2A, type 2B. Now slow and fast, resistive, fast, fatigable. Now contraction speed is slow, this is fast, and this is fast. There are, depending upon the composition, cellular compositions. If you look at the fatigability, this is low fatigability. It means it can stay there for a longer time. This is a medium fatigability, this is very highly fatigable. Motor neuron size, this is small motor neuron. Motor unit size also is small. So this is a large motor unit, it means, and there are more number of muscles attached to it. There are more and more types being identified. For example, recently people have come up with 2x. 2x is nothing but the FOG and FG combination. Combination of this also people have found out, and in fact there are much more types recently found out. So this is the now all or none Bowditch law. It depends upon the graded potential equal to the action potential. Okay. This law is very important for the size principle. Size principle, slow twitch motor are recruited first, threshold for activation depends on the shortening rate, fast twitch recruited last. Essentially it is nothing but the small motor unit or large motor unit. Successive motor units are recruited later. Size of the motor units recruited depends upon the current tension, depends upon the requirement. If you require more force, then the next level of motor unit is recruited, and then the reverse order the largest one. Okay. This is to show that the small motor units, suppose if this is the amount of required force, it is increasing, first a small motor unit, low stimulation threshold is required, and then the larger motor unit, higher stimulation threshold, and then largest later highest stimulation requirement. Okay. This is called the size principle we saw. So what we have seen is only the recruitment. There is one more way of controlling the force. So that is called as a rate coding. In the initial, when we started this lecture, we saw that the frequency of the stimulation can also change the force. Okay. That is called the rate coding. So how frequently you are going to stimulate the force, so stimulate the muscle, that can change the force developed by the muscle. Okay. While recruitment is the spatial summation, many muscles are adding the force. Rate coding is going to now temporarily summate the forces. So muscle can change its force by two ways, by recruitment and rate coding. These two things is very important to remember. Rate coding refers to the motor unit firing rate. Active motor unit can discharge at a higher frequency to generate greater tensions. Recruitment versus rate coding. Smaller muscles rely more on the rate coding, larger muscles of mixed fiber types rely on more recruitment. So I am going to show you. So this is what I mentioned over here. Larger muscles of mixed fiber types rely more on recruitment rather than the rate coding. Smaller muscles rely more on rate coding rather than the recruitment. Okay. The firing of individual motor units occurs as a stochastic process, as it is not the deterministic as we have seen it. Firing rate is a better term to describe the global changes in the firing frequency, that is the rate coding. Okay. So, this point is very important, that now motor units, which larger motor units are using the recruitment, more of recruitment, smaller motor units are relying on the rate coding. I wanted to highlight it, it is very important to understand. Now, we have an idea about how muzzle is generating the force. We have taken only now the muzzle alone. So, in the earlier class we saw the sensors measuring the length, velocity and the force. Now, we have looked at only the development of the force. Haptics is nothing but a control system, right, movement, and then really making an interaction with the objects, generating the force. So, in the next class what we are going to do is that we are going to use the sensors and the motor force developments together, and then see how these muscles are controlling the forces using the information coming from the sensors. Okay. We have the muzzle spindles, we have the Golgi tendon organs, which is measuring both the length and velocity and force, right. What information is going to use for generating for controlling the force generated by the muzzle is what we are going to see. Is it going to use a length based control, or is it going to use a velocity based control, or the force based control? In the robotic literature, if you look at it, there are no position based control system, right. The robo end effector is control for the position or the force or the mixture of anything, but what is that our human hand, what control system is it actually using it? We will see it in the next class.